Instantaneous rate of change. Develop an algebraic expression to represent the instantaneous rate of change for the function f of x equals to x squared minus 2x minus 1. Use this expression to determine the coordinates of the vertex of this function. So, to find instantaneous rate of change, we can use difference quotient method, right? So we can take a point in generals as a, x equals to a. So, and then find instantaneous rate of change between 2 points, one at a, the other at a plus h. So instantaneous rate of change we can write like m at a, at x equals to a, is equals to limit h approaches 0 for f of a plus h minus f of a over a plus h minus a, right? That gives us limit h approaches 0 of f of a plus h minus f of a over h, right? So let's calculate f a plus h minus f a. So we get limit h approaches 0. A plus h means you have to substitute x as a plus h. So we get a plus h whole square minus 2 times a plus h minus 1. So that is f of a plus h minus f of a means we'll put a for x, which is a square plus 2a minus 1 over, let me put that in brackets, right? Otherwise it will be wrong, right? Divided by h. Now let's simplify this numerator. So we get, so first expand a square plus 2ah plus h square, open this bracket, minus 2a minus 2h, and then we have minus 1, minus of a square plus 2a minus 1 over h. Now all these terms for fa will get cancelled out. It's kind of important to note. Always it happens, right? Plus 2a, here we have minus 2a. So yeah, that is a mistake. It is x squared minus 2x. So that is important, right? So it's kind of a check for us. This is my mistake, right? It is x squared minus 2x minus 1. So minus 2a minus 1. So it has to cancel. So that is also a check, right? Do you see that? They will always cancel out, right? And now we have a simplified expression where h is common. Do you see this term? H, H, H. So there are these three terms and h is common. That's always like this, remember. So we get in the numerator 2ah plus h square minus 2h over h, right? H is a common factor. We can divide each term by h. And then we get limit h approaches 0. And this is 2a, 2h divided by h plus h minus 2. Correct? And now, limit of this function as h approaches 0 is 2a minus 2, right? So it approaches approximately 2a minus 2. So that is the instantaneous rate of change of our function at any general point x equals to a. So that is the instantaneous rate of change, and that is the algebraic expression to represent instantaneous rate of change. So we got that part. The answer is the instantaneous rate of change for f of x in general is 2a minus 2. Now the second part is here. Use this expression to determine coordinates of vertex. So at vertex, this is a parabola. So this parabola is going to open upwards, correct? So at vertex, our tangent is going to be horizontal, right? It should be horizontal. So that means the instantaneous rate of change which we calculated, so that means m equals to 2a minus 2 should be 0, right? So that is the slope. So knowing the slope, which is 0, we can find the value of a, right? So we will do that part now. So if 2a minus 2 is 0, then what is the value of a? So that is what we are going to calculate, correct? So let's calculate. So slope m equals to 0 for the vertex, and therefore 0 is equals to general equation, which is 2a minus 2. Now from here we can calculate that a is equals to 1, right? So 2 times 1 is 2, 2 minus 2 is 0. So this implies that a equals to 1. Now if a is 1, what is f of a? Then f of a will be, rather f of 1 will be, I'll put 1 here, right? So it is 1 minus 1 times 2, which is 2 minus 1, and that gives me a value minus 2, correct? So that is the vertex, correct? So we can write down now, our answer is that general term, general instantaneous rate of change is m equals to 2a minus 2, and the vertex is at a equals to 1, and the y value for this function at 1 is minus 2. So that is the coordinate for the vertex. I hope you understand and appreciate our method. Thanks and all the best.